Okay, so this video is going to cover the inclined plane. So just a little bit of history on the inclined plane. When you think about it, you probably think back to the days of the Egyptian pyramids, because they actually used inclined planes to push heavy objects up the plane in order to carry them to an elevated distance, right? And they used this when they were building the Egyptian pyramids. Now, one interesting fact is that the last of the 6 simple machines to be recognized was the inclined plane. Okay, so the inclined plane is pretty easy. When we talk about the IMA, it's going to be the same question, the same equation that we're familiar with, which is the DE over the DR. We just have to define for an inclined plane what those values are, okay? So a DE, if we remember, the DE is the distance traveled by the effort force. So in the example here, we have an inclined plane, okay? And we have an effort force pushing this cart up the ramp, right? So that's FE. Now the distance traveled by the effort force is going to be the length of this ramp, okay, which we're also going to call L. In this case, it's 15 feet. The distance traveled by the resistance force is going to be dr. And in this case, the resistance force, right, which is the force of gravity, Fr, is going to be 4 feet. Okay, so if we were to calculate the IMA of this particular lever, the length is 15 and the height is going to be 4. Okay, and that's how we get the IMA for this plane. Okay, and what about the AMA? The AMA is going to be the equation that we're familiar with, which is the force resistance over the force effort. And again, the force resistance is going to be the force of gravity. And the force effort is going to be what effort force we're applying to push this particular car up the ramp. Okay, so if we know our FE is going to be 20 and our FR is going to be 50, then we can solve for our AMA, right, which is 50 over 20. Okay, we come up with 2.51. And then the efficiency is simply going to be the AMA divided by the IMA. So we calculated the AMA to be 2.5, right? And the AMA we previously calculated to be 3.75. And that gives you an efficiency of 67%. Okay, so here's another problem. If we want to calculate the IMA, right, the DE over DR, so what do you think that would be? Right, so the DE, again, is going to be, if we have a box here, right, and we're pushing it up this ramp, the DE is going to be the distance traveled by this effort force, which is going to be L, which is going to be 15 feet. And then the DR would simply be the force of gravity, or FR, and that height, the distance that it would travel would be the height, or H, which would be 4 feet. Okay, so DE over DR would be 15 over 4. Okay, now here's another problem. The DE over the DR here would be, right, so we just agreed this is going to be our DE, which is 20 feet, and our DR will be 5 feet, so this is going to be 20 over 5. Okay, so real quick before I move on, we get an IMA of 4, and let's not forget what the IMA means, right? So mechanical advantage. So what this says is that I'm able to apply 4 times less effort force to actually push the cart up the ramp compared to the force resistance, right? So if we just, for simplicity, say the box weighs force of gravity, the FR would be 4, and the effort force that I would apply would be equal to 1, right? So our effort force is 1, our resistance force is 4, so we've been able to multiply the force magnitude by 4. Okay, so one more thing I want to review is we talked about the IMA and the AMA, right? And sometimes you're not always going to be given the slope or the L, and you're not always going to be given what we call the rise or the H, right? So one second here. Okay, so we said earlier, remember that this is going to be, use a different pen. This is going to be the DE, and this was going to be your DR, right? Okay, well, you're not always going to be given the L or the H. Sometimes you have to solve for that, okay? So if you remember back to geometry, the L is on a right triangle is what we also call the slope. And then the H is what we call the rise, and then the horizontal distance here is what we call the run. Okay, so there's a few equations that you need to know. First of all, the slope is going to be the rise over the run, so you should remember this from basic algebra or geometry. Okay, so you can calculate, if you have two of these values, the L, the H, or the X, you can always calculate the third by using this equation. And the other equation is called the Pythagorean theorem, okay? And you can also use the Pythagorean theorem to solve for one of these unknowns. If you know the H, which is the rise, and you know the run, which is the X, then you can solve for the slope, which is the L value, okay? And then the third one is, when we talk about inclined planes, we do have to consider the angle that we're designing the inclined plane from. And that equation is going to be sine of theta, or the angle, is equal to the H over the L, right? So if our inclined plane is going to be angled at 45 degrees, right? Then if we're given the L or the H, let's say we're given the L, right? Then it would be sine of theta times the L value. Let's say the length is, I don't know, 5 feet, right? And then we can calculate the H from that, okay? So these three equations are important for you to understand, and you should have been introduced to these in algebra or geometry, and we're going to be using them in this class to solve for the unknowns values for the inclined plane. Okay, the other thing which may be new to you, this is going to be the physics review, okay? So the only thing I want to mention when we talk about inclined planes in terms of physics is there are 4 different forces acting upon an object that is being pushed up an inclined plane or even coming down an inclined plane, okay? We already talked about force effort, right? Here. This is force effort. That's the effort force that we're using to push the block up the ramp. We also talked about force gravity, right? So this is going to be the resistance force, okay? So we can call it Fr. It's also called Fg for force of gravity. The other one we have talked about, and that's called the force of friction, okay? And if you remember when we were talking about, early on when we were talking about leverage, we talked a lot about work loss and frictional losses. And I also talked about if you push a block across the table, right, depending on the frictional factor for that table, whether it's sandpaper or a smooth surface, depends on how much friction you're going to lose, right? So friction is always going to push against the effort force, right? So the more friction you have, the more effort force you're going to have to put into pushing something across the table. And then we also have something called a force normal, okay? So if I'm holding, let's say, a pin in midair, gravity is going to be pushing down, but there's also going to be a force normal pushing back up, right? If there was no force normal pushing back up, then the pin would continue to fall endlessly to the ground and beyond. Even if it does fall on the ground, there's still a force normal from the floor pushing against the force of gravity. Okay, so these are 4 terms that you need to know. Fn is the force normal, Fg is the force gravity, which we also know as force resistance. We know Fe, force effort, and we know frictional force, okay? So that's the math review, that's the physics review. And then I also want to challenge you to look over the scenario here, okay? So in this scenario, we have a wheelchair ramp, which is being designed according to ADA code. And it states that when you design a wheelchair ramp, you have to have a 1 to 12 ratio for the slope. Okay, so let's go back to what slope means. The slope is going to be, the slope here, right, which is the length of the ramp, is going to be equal to the rise over the run. Okay, so what that says is that for every 12 feet of height, right? Sorry, that's not right. Be the rise over the run. For every foot of height, you have to have, for every foot of vertical height, you have to have 12 feet of horizontal length, okay? And that keeps the angle from getting too steep, because you don't want somebody in a wheelchair trying to push themselves up a very steep ramp, because it would be very difficult, right? So the ADA code states that it has to be a 1:12 ratio. Okay. Now, we're also given that the length from the floor to the door, which is on the other side, there's some steps, has to be 2 feet. Okay, so if we have a 1:12 ratio, right, and we know that the height is going to be 12 feet, what do you think the run has to be? Okay, so think about that and try to solve that in your engineering notebook.